This video is submitted as evidence for Project Catalyst Fund 11, Proposal Food Traceability by Cardano with the ID 11000136. I'm Christian Rojas, and this is a walkthrough of the prototype running on Cardano testnet. Every participant is onboarded through a controlled process, approved by an administrator before getting access. This is the login screen for a producer account using the operational identifier assigned during onboarding. After first login, the producer completes account verification, confirming role and sector, in this case, producer coffee. Submitting this sends the request to the administrator for approval before any blockchain interaction happens. On the administrator side, once the verification request is approved, the platform automatically provisions an internal Cardano wallet for that account. Here's the resulting address. The producer never handles seed phrases or manual wallet setup. The platform manages that entirely in the background. The producer registers a new plot. Owner information is pre-filled from the verified account. No need to re-enter identity data. Instead of relying on a manual address, location is set directly on satellite imagery. The producer selects the state, then zooms into the actual plot, giving a level of precision that a written address could never guarantee. The producer draws the exact plot boundary. This generates the GeoJSON data that will become part of the on-chain evidence. Once submitted, the plot appears in the producer's registry alongside any others they've registered, each one already linked to its own blockchain record. From here, the producer can open any plot to review its details and confirm the on-chain evidence. Here's the key part. The platform confirms this plot has a public, verifiable blockchain record, and it explicitly does this without exposing sensitive data like exact coordinates or geospatial files publicly. This links directly to Cardano testnet. A confirmed transaction minting a token that represents this exact plot registration event. And here's the detail that matters. The on-chain metadata stores a hash of the plot's geolocation data, not the raw coordinates. The event is verifiable and tamper-proof, while the sensitive geospatial data itself stays protected. Every harvest starts from an already registered plot. This one, Coffee Plot Cardano, was previously registered on-chain. Its geolocation and ownership are already verified. Now we are going to log the harvest that comes from it, which means this new event needs to carry that connection forward, not start from zero. Registering a harvest starts by selecting the originating plot. This is what creates the link between the two events. Producer information is already pre-filled from the verified account. Then we define what this harvest actually is, the commodity, in this case coffee, and the quantity being reported. The producer records the harvested quantity in kilograms, along with the start and end dates of the harvest window. A photo can be attached as supporting evidence. This gets uploaded to IPFS and referenced permanently in the on-chain metadata, so the visual proof stays tied to this specific event. Once submitted, the harvest batch appears in the producer's records alongside every other batch they've registered, each with its own quantity, HS code, and harvest dates. And each one already has a digital product passport generated, ready to be inspected. This is where the chain becomes visible. The digital product passport shows the full journey so far, plot as the origin, harvest as the current stage, with processing and export still pending. It links directly back to the source plot and shows two separate pieces of on-chain evidence: the NFT certifying the harvest event itself, and the fungible token representing the 80 kilograms of coffee cherry as a transferable, trackable quantity. And this is the proof that matters most. The transaction metadata explicitly references the previous object and the previous transaction hash. This isn't just two separate records that happen to look related in our database. The harvest event is cryptographically linked to the exact plot it came from permanently on Cardano testnet. Tracing back to that source plot confirms the same privacy principle we saw earlier. The geolocation evidence is represented as a hash, not raw coordinates. So this harvest is provably tied to a real verified plot, without exposing where exactly that plot is. At this point, the harvest batch already carries a verified history, its origin plot, its quantity, and its own blockchain evidence. The next step in the chain is custody, moving that physical product from the producer to a collection center and making sure that movement is just as traceable as everything before it. The producer initiates the transfer by selecting which harvest batch is being handed off. In this case, the same 80-kilogram batch we just saw. Producer information is pre-filled, and just like with harvest registration, a photo can be attached as supporting evidence of the physical handoff. On the receiving side, the collection center has its own verified account with its own operational identifier COF-COLL-0001. This is a different role in the platform with different permissions, but it went through the same governed onboarding process as the producer. Once the transfer is confirmed, the batch appears in the collection center's own registry. Alongside every other batch it has received from different producers, each one keeps its own digital product passport, now updated to reflect this new stage. The passport now shows 4 stages instead of 3, with custody marked as the current one. It clearly shows where this batch came from and who now holds it. And just like every other step, this transition produced its own on-chain evidence, an NFT for the custody event itself, and a fungible token transfer representing exactly how much coffee physically changed hands. On-chain, this isn't just a symbolic record, it's an actual fungible token transfer. 50 units of coffee cherry move from the producer's wallet to the collection center's wallet, with the metadata explicitly naming both parties and the exact quantity involved. And again, the chain of custody is enforced cryptographically, not just visually. This transaction references the exact previous transaction hash where the batch was originally created. So anyone auditing this can walk backward through every hand this product passed through, all the way to the plot it came from. And the collection center sees the exact same verified history. There's no separate version of the truth depending on who's looking. That consistency is what makes this evidence usable for compliance, not just for internal record keeping. Once a batch is in the collection center's custody, it doesn't necessarily move forward alone. In practice, a center receives batches from multiple producers, and at some point, those batches get consolidated into a single processing lot. That consolidation is the next event we need to capture on-chain. The collection center selects which harvest batches are going into this new processing lot. They can be from different producers as long as they share the same commodity. Once the batches are selected, the platform automatically calculates the resulting HS code and total quantity in kilograms. The operator doesn't enter those numbers manually, which removes a common source of human error in aggregation. The result is a new processing batch, PB-COF-COLL-00001-2607070935. But critically, the record still lists every original harvest batch that went into it. Nothing about the individual origins gets lost in the aggregation. It's a many-to-one relationship, fully preserved. The passport now shows aggregation as the current stage, with custody and everything before it marked complete. And this is where the traceability model really proves itself. Instead of just showing one flattened total, it lists each source harvest batch individually, with its own weight, and gives a direct link to inspect that specific batch's full history, right down to which plot it came from on-chain. This many-to-one relationship isn't simplified away either. The metadata explicitly lists multiple previous object IDs and their corresponding transaction hashes, 1 and 3 per source batch. So this single aggregation event carries a verifiable link back to every batch that contributed to it, not just a generic reference, and this works both directions. From the aggregated lot, an auditor can click into any individual source batch and walk its entire history backward, custody, harvest, and ultimately the originating plot, each step still carrying its own independent, verifiable evidence. Consolidation for processing efficiency doesn't come at the cost of losing that granular trail. Once harvest batches are consolidated into a processing lot, that lot is ready for its first real transformation. In coffee, that's wet milling, the process that converts raw coffee cherry into parchment coffee. This is a physical change to the product itself, not just a change of hands, so it needs its own distinct event on chain. The collection center requests the wet milling process, starting from the consolidated batch. Just like every previous step, the platform pre-fills the operator's identity. The only real decision here is which batch is going into processing. Selecting the batch here is what creates the link backward. This transformation event will carry a permanent reference to exactly which aggregated lot it came from. The same pattern we've seen at every previous stage. The operator specifies the type of transformation, wet milling, along with the input quantity and unit. This is the step where the product legally and physically changes state, from raw cherry to parchment coffee, and that state change gets explicitly recorded, not just implied. Once submitted, the result is a new processed batch. Note the quantity changed from 130 kilograms of raw cherry to 100 kilograms of parchment coffee, reflecting the natural yield loss of wet milling. That transformation ratio is captured as part of the permanent record, not lost in the process. The digital product passport now shows 5 stages, with wet milling as the current one, and it still links directly back to the aggregated batch it came from. The product identity has changed, from coffee cherry to coffee parchment. but the traceability chain hasn't broken. It's simply extended to reflect what actually happened to the physical product. On-chain, this is represented as an explicit transformation event. The old asset, coffee cherry, doesn't just disappear. The metadata records exactly what type of transformation occurred and what new asset came out of it. 100 kilograms of coffee parchment as a distinct fungible token, and this record is consistent no matter where it's inspected from. The same evidence, the same numbers, whether you're looking at it from the platform or directly from the blockchain explorer. This is the most complete metadata we've seen so far. It references the previous transaction, the previous object type, even the specific token transfer transactions involved in both the input and the output. Every fact needed to reconstruct exactly how this batch became parchment coffee is here, permanently and independently verifiable. From a single plot to a physically transformed product, every step of this journey is on Cardano testnet, verifiable, linked, and impossible to fake. This is what compliance evidence looks like when it's built into the supply chain itself instead of assembled after the fact. That's the full traceability flow, from plot registration to a physically transformed product, every step verified on Cardano testnet. This is the prototype built for Proposal 1100136, Food Traceability by Cardano, Fund 11. Thanks for watching.